So in this video, I'm going to solve the problem 2 to the power of 19 minus 2 to the power of 18. So I want to find the value of this problem. So for my solution, I'm going to start by rewriting my problem here. So 2 to the power of 19 minus 2 to the power of 18. And to start off, I'm going to rewrite 19 here as 18 plus 1. So I get 2 to the power of 18 plus 1 minus 2 to the power of 18. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 18 plus 1 is equal to 2 to the power of 18 times 2 to the power of 1. And now I have this minus 2 to the power of 18. Now from here, because I have two terms that are the same, I can factor out 2 to the power of 18. So I get 2 to the power of 18 times, 2 to the power of 18 times 2 to the power of 1 divided by 2 to the power of 18 is simply just 2 to the power of 1, and negative 2 to the power of 18 divided by 2 to the power of 18 is negative 1. So I get 2 to the power of 18 times 2 to the power of 1 minus 1. And this is equal to 2 to the power of 18 times, 2 to the power of 1 is 2, so I get 2 minus 1, which is equal to 2 to the power of 18 times 1, which is equal to 2 to the power of 18. So I get 2 to the power of 18 as my answer. Now, there is actually another method of solving this problem. So going back, our original problem was 2 to the power of 19 minus 2 to the power of 18, right? And what we did was we wrote 19 as 18 plus 1, and we solved it by factoring out 2 to the power of 18. So now, what if instead of rewriting 19, I rewrite 2 to the power of 18 as 2 to the power of 19 minus 1. Now, the way I'm going to solve this is I'm going to rewrite 19 minus 1 as 19 plus negative 1. Now, I can still use that property that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of 19 plus negative 1, that's going to equal 2 to the power of 19 times 2 to the power of negative 1. So I can still do it. Now from here, my greatest common factor from these two terms is 2 to the power of 19. So I get 2 to the power of 19 times 1 minus 2 to the power of negative 1, which is equal to 2 to the power of 19 times 1 minus 1 half, which is equal to 2 to the power of 19 times 1 half, which is equal to 2 to the power of 19 times 2 to the power of negative 1. And 2 to the power of 19 times 2 to the power of negative 1 is equal to 2 to the power of 18. Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 80. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation here, a to the power of x is equal to 80. And now, my first step to solving this problem is rewriting 80 as 8 times 10. So now I get 8 to the power of x is equal to 8 times 10. And now, I can go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to, all that's left here is 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over 8, well, 8 is the same thing as a to the power of 1. And a to the power of x over a to the power of 1, by using this property, is going to equal a to the power of x minus 1. And this is equal to 10. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x minus 1 is equal to log of 10. And the reason I take the log on both sides is because now I can use the property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So log a to the power of x minus 1, I can move x minus 1 to the front, and I get x minus 1 times log 8 is equal to log 10. And this property is really important because before, x was an exponent, and it's really hard to solve an exponential equation, but now we moved x, and now it's a real term, and it's much simpler to solve. So now what I'm going to do is distribute my log x here. So now I get x times log x, or log 8, which is equal to x times log 8, minus 1 times log 8, which is just log 8, is equal to log 10. And now I'm going to add log 8 on both sides. So then these two cancel out, and I get x times log 8 is equal to log 10 plus log 8. And now we want to isolate x. So what I'm going to do is get rid of this log 8 by dividing both sides by log 8. So then these two cancel out, and I'll be left with x is equal to log 10 plus log 8 over log 8. Now log 10, that's equal to 1, if you guys already know. So I get x is equal to 1 plus log 8 over log 8. Now, this is the same thing as 1 over log 8 plus log 8 over log 8. And log 8, these two cancel out, so I'm left with x is equal to 1 over log 8 plus 1. And log 8 is equal to 0.9031. So I get x is equal to 1 over 0.9031 plus 1. And 1 over 0.9031 is equal to 1.1073, and this plus 1 is equal to 2.1073. So this is my answer.